Hi everybody. So this asks us to compute the velocity vector or the tangent vector. This means the same thing to a curve. And a curve is, taking time and then moving around in space. And we're supposed to use the limit definition of derivative to do it. Okay. And what curve? Well, this specific curve. Okay. So I'll begin with some words. Velocity at time t should be instantaneous, whatever that means. We'll see what it means in a second. Instantaneous. Distance over time, right? That's what speed is. Speed is distance over time. But now velocity, we're going to use the vectors in space that we're moving around through space. And it'll work the same in any dimension, actually. So f of t is some point in space. And so, let h be a real number, then f of t plus h is another point. And I'll even say it's along our curve. Right? Our curve is all the points f of t for all different times. And so let's draw a picture. So you should have pictures as well. So maybe here is a curve, and we're going that way, and maybe it continues, and maybe it came back from over here. And let's say that f of t is here. That's f of t. Well, then let's draw a couple f of t plus h's. So yeah, maybe I'll start with this. Maybe this is f of t plus h. Some h, is a new real number. So f takes, it gives us a point in three-dimensional space, so it's over here. Then we can look at the distance. The distance is this vector, final minus initial. And then, if we let h shrink a little bit, we get a different, if now this is a different f of t plus h. I'm not going to make up like h2. No. I'm not even going to clutter my picture with any of that. I'll make a couple more, maybe this one. And so we see as h goes to 0, as we make smaller and smaller h's, we see that we get like really small vectors. And as h goes all the way to 0, we're just going to get the 0 vector. So that's no good. So let me say that. Final minus initial gives distance vectors. Let's put them in a formula. Well, what is this distance vector? Well, it's final minus initial. But as h goes to 0, these shrink to the 0 vector. And that is no good. Velocity shouldn't be just the 0 vector. Velocity should be some actual vector. Like, really, in our heads, we're thinking that the velocity right here should be a vector like that. And the velocity here is a vector like that. And the velocity over here is a vector like that. And everywhere you are, the velocity should be sort of tangent to the curve. Now this little vector here looks pretty tangent, but it's too short, so we need it to be bigger. So rescale by dividing by h, right? That's our time. So distance over time is velocity. So the time step between t and t plus h, well, they differ by a time h. Okay, and you can scale a vector. You can divide a vector by a number, and that'll, in this case, make it bigger. So now what we get, in formulas. So now we're switching, we have words, we have pictures, let's do formulas. The velocity at time t will be, well, this distance vector, which is going to be too small. But then we're going to make it the right size by dividing by this very small number, which will actually make this vector bigger. Limit as h goes to 0. I guess technically people usually write this over here somewhere, but it doesn't matter. Just write it somewhere. Tell me that you're actually taking a limit, and I'm good. So what is this? So, in our specific formula is this curve. It's a very specific curve for our specific curve. Now let's go back to formulas. V of t is, okay, what's f of t plus h, and what's f of t? Well, I'll just write it again. Remember, t goes to t squared, t to the third. That was the formula for f. Okay, so what's t plus h? Well, it's t plus h, and then it's t plus h squared. You need to take whatever you see here and you plug it in to those three spots. So here we have t plus h to the third. And then what's f of t? Well, that's just this. So now we do, these are vectors, t squared, t to the third. And I just plugged in. These are vectors. Now, h is a real number. Remember, I told you that. I specifically told you what the symbol h is. You can call it by a different name. You could call it smiley face, but that's just hard to write a lot of times. And so people t and h seem to be, it doesn't matter what you call it. And then we just divide by h. Okay, so let's calculate. So calculate. So you can subtract vectors. Subtract vectors. So, well, first of all, let's calculate squaring things and cubing things. Notice, this is this. If you don't know that right away, this should be easy. So take your time and practice that. You should be able to do that formula right away. Same with this formula. It is worth your time. It will appear again. So that is that same vector. I'm just expanding it out, and now I have to subtract a second vector. And then I have to, at the end, divide by h. Okay, so let's just subtract these vectors. T plus h minus, well, I'll just write it out. T plus h minus t, and then I have t squared plus 2th plus h squared minus t squared, t to the third plus 3t squared h plus 3t. There we have it. And then this vector I'll divide by a number. Now, all I did here was subtract vectors. I'm just using formulas to subtract vectors. Okay? We know that in the picture, the subtraction of the vectors was final minus initial. So if I have, maybe this is 0, 0, final minus initial, what I get is this vector here. Final minus initial. But we don't clutter our picture. Our picture looks cluttered enough as it is. Okay, so that's the pictures of what I'm doing, but I don't have to actually draw pictures to compute. I can just subtract. Okay, so now t minus t. T squared minus t squared. This is great. T to the third minus t to the third. This will happen every single time. Even when I give you, see this formula is in blue, I might give you a different formula. Something like that will happen. And so what do I get? Well, I get, let's take this h and let's just put it like that. Just a different way to, now what do I have? I have h there in the top. Now I have this remaining. And I have this remaining. Okay, divide by h in each component. This divide by h hits each of the numbers. That's how we scale a vector, right? 5 times 1, 2 is 5 times 10. Or, sorry, 5 comma 10. Like, the 5 comes in and hits every single thing. That's how we scale vectors. So what do I get? I get h divided by h is 1. This becomes a 2t, and this becomes an h. This becomes just a 3t squared. And then the rest have h's. Even after I cancel, they still have h's. And now, what do? I say, well, as h goes to 0, we get the velocity at time t is equal to 1, 2t, 3t squared. So the velocity at time 2 is the vector 1, 4, 12. It's a specific vector. You're moving through space, and at moment, at f of 2, you're at this point on your curve, and the velocity is this vector right there. Okay, so that's in my head. Yeah, I'll leave that. That's okay. But now, are we done? Let's see. Calculate the velocity vector for a curve using the limit definition of derivative. And do it for this curve. Yeah, we did it. That's awesome. So, I'm just going to wrap up. Notice the curve has velocity. Okay, so the curve, and now I'll put formulas. What was our curve? T goes to t squared, t to the third. And it has the velocity, a new function of t. At every moment, every time, there's a velocity vector. And what is it? Well, its formula is 1, 2t, 3t squared. And look at that. The derivative of t is 1. The derivative of t squared is 2t. The derivative of this is that. And you know that from single variable calculus. This is as expected from single variable calculus, but we have confirmed it in the case of higher dimensional space. Maybe this happened all in 3-dimensional space. And we did it using the limit definition. Okay, so when you're studying, you need to take out a blank sheet of paper and try to recreate something like this. It should have words, it should have pictures that are, correctly labeled, and it should have formulas and calculations like this. And, this is a long question, but it's not that long. You can do it. I was quizzing myself, so this is the second time I solved it. And the first time, it looked like this. Here's my calculations. And I get the same answer.